Hello, everyone, and welcome to our webinar. Today, our topic is how to integrate coding into core curriculum, presented by Mark. So today, this is the agenda. I'll give you a little introduction about BSD and then pass it over to Mark to take you through our webinar today. And then we will have some time for Q&A in the end. So if you have any questions along the way, just feel free to message me in chat and we will address these questions at the end of the webinar. So a little bit about BSD. We are an education startup where we design, develop, and deliver programs to enable teachers to bring real-world technology into the classroom. So this includes digital skills, digital citizenship, and we provide curriculum, also the platform, and also training and support, which is professional development, to the teachers and to schools to create real impact. So I'll pass it over to Mark to tell you more about himself.
Thanks, Eva. Let me just share my screen. There we go. Can you see my screen, Eva? Perfect. Hey, everyone. My name is Mark, and I am the Vice President of Education at BSD. And I oversee curriculum development, webinars, professional development, and upholding our pedagogical foundation, as well as what I currently do with BSD. I am studying for my PhD in educational technology at Chiang Mai University in Thailand, which is where I am currently located. Eva's in Hong Kong and I'm in Thailand. We kind of have a global team of operations. And what I want to share with you today is more about how we can look at coding across the curriculum with some examples of things that we do at BSD and some things that you can try on your own. But first, I want to talk a little bit about misconceptions. So there are a lot of misconceptions out there about coding and its use or its value, or who should be doing it or who shouldn't be doing it. So let's take a look at some of these common misconceptions. The first one is that coding should only be for high school students. So we work with schools all over the world, and we especially hear this probably from primary teachers who say this. Coding is not in my curriculum, that's for high school students. And I think in the past, generally, it has been true that coding is typically only available as an elective or as coursework for high school students. But as more and more coding platforms become available, we can start coding as young as kindergarten. For example, there is a robotics platform that we just recently saw that is meant for students who don't even know how to read yet. So it uses color and sound and movement, and students, in kindergarten or younger, program the robot by following a sequence of patterns of numbers and sounds. So it's kind of like a robotic Simon Says. So the student programs it with the colors and then the robot follows along. And that starts to build fluency in algorithmic thinking, which is what is needed for coding. So then, in primary, students can start to program with block-based coding like Scratch and MakeCode and others. So there is a kind of an entry point for coding, no matter what the age of the student. And you can probably look back in some of our past webinars to learn more about those different entry points and different coding languages. Another myth is that coding is usually only taught by the technology teacher. So if your school does teach coding or programming technology in some way, shape, or form, it's probably done in a special classroom. So there's the technology class or the computer lab, and there's the technology teacher who works in that classroom and is delivering IT and coding and programming subjects. But we also find that coding can be integrated across any subject by any teacher who's just willing to do so. So if you're a teacher, a math teacher, a science teacher, literature teacher, or language teacher, interested in integrating coding and programming into your curriculum, well, you can do that. And there are lots of tools that can help you with that. At BSD, we just happen to have one of those tools available, and we'll share a little bit more about some of our projects and how those are helping teachers across multiple different subject areas. Myth number 3 is that you need a computer to teach coding. And this one is probably the most unbelievable myth, because coding, well, that happens on computers, right? But we can start thinking about coding. We can start thinking about computational thinking and algorithmic thinking by solving puzzles, by doing offline activities. So we at BSD have created a computational thinking workbook, and we are sharing that for free for anybody who wants to start using it as a kind of an introductory point into coding. But maybe you're not quite ready to start programming on the computer, but you see the value in that, and you want students to start learning about how to think computationally. So Eva, if you could share the link out to our participants for this computational thinking workbook. It's got several different activities. Some are 5 minutes, some are 30 minutes. But they're all kind of either a hands-on activity, or there's some kind of a workbook page that guides students through an activity. You can print these out yourself, download the whole thing, or you can just guide students as the facilitator through these activities. It's up to you how you want to use this, but no computer is needed for you to do the activities. We find that this is a great starting point for students who haven't done any coding before. So this starts to kind of prepare the mental mind thought, like how do you think about abstraction? How do you think about breaking programs down into smaller chunks? How do you start to think about logic, which is needed for programming? These things all help gear you up for actually coding and programming. So now let's talk a little bit about ways that we can integrate coding across the curriculum, and we'll share some different examples from different subject areas. Math tends to be the most logical connection for programming, because the nature of math and coding are similar, especially if you look at programming languages like Python, where there's one of the first activities that you do is learn how to use the maths function in Python. But in order to strengthen the math curriculum with coding, like I mentioned earlier, algorithmic thinking is huge. Some examples of projects that we have at BSD, we have a project where you can code a pie chart. So a pie chart is, can be used in pretty much any realm of maths, even primary. And so students can figure out which data they're going to use. Then they code the pie chart, choose which color, figure out the percentages, and then they produce a visual representation of that. Another project that we have is code a timer. This is the Python project in which they need to learn about the Python timing library. And so they can import time as a function and then use it to count up or to count down or to set a specific duration. We also have a project called the Money Saving Calculator, in which students choose a desired amount of money to save, and then they kind of put in their expenses and put in their inputs and figure out what's the best way to accumulate that amount of money, or how long it would possibly take. These are just some examples. If you are good at coding or programming, if you're a teacher that's interested in this, you could probably come up with a lot more different ideas, but we just want to share some possible examples of things that you can do as a maths teacher. Eva, when you were teaching, did you teach all subjects?
No, I taught media studies, so I was actually surrounded by technology.
You want to give us an example of a coding project from the media studies curriculum?
Yeah, so a coding project that we would use in media studies or even film studies for students is that we can use a blog project for students to log their production process. So they would do entries and reflect on how well their film production is going, how well they're planning the production. So it becomes this really cool piece of reflective work that they can keep going back to. And of course, it's an easy link to share with for applications as well in the future for college or university. So yeah, that's one of the ones that I always fall back to. A blog project is always a great entry point.
Yeah, agreed. I think a blog or a reflection or some kind of portfolio piece that showcases what students have made is an easy win for any project in any subject. Well, I was a science teacher, so it was easier for me to come up with science examples. So in the realm of how do we connect science and coding together, well, there's a lot of physics simulators. So if you've ever played a video game, or if you've made a video game, you'll realize that there's a lot of coding that goes into the behavior and the mechanics of the characters, the backgrounds, the worlds. And so those are all done using physics simulators. And the mathematics behind physics simulation gets really heavy. For example, the code just to generate the gravity effect of a bouncing ball can be quite complicated. So we can learn a lot about, we can even bring in the maths and the science together to learn about that. Some other examples that maybe come from a primary age. One thing that we've done at BSD is we have a life cycle visualizer. So you take the life cycle of a frog, a butterfly, etc., plop in the images and the text descriptions, and students can create that. We have a pop-up periodic table, which uses JavaScript to, when you click on one of the elements, a pop-up shows up on your screen, that it gives you a little bit more information about it, another picture of it, that kind of thing. So it's a bit more interactive instead of just a static image. And then we also have a digital experiment log. So when students are conducting a scientific experiment, they can put images, they can put data, they can drop in a chart or drop in a table, so they can keep the data over a long period of time and then reflect back on that later. So these are just examples, and the ones that I'm mentioning, like the ones that we have at BSD, the life cycle, pop-up periodic table, these things can be created outside of BSD. We just happen to have them as part of our curriculum. If you're a literature teacher, writing teacher, English teacher, or language teacher, there are lots of different examples. Eva mentioned a blog earlier, which is a very versatile type of project. The example that I came up with for this one was, though, imagine that you read a book. So that's a common activity in the literature and writing class, to read a novel. Well, what if you were to then create a blog, and you would write that blog from the perspective of one of the characters in the novel? So I think it's a kind of an interesting way to be creative with the writing, but then also we're going to code and make a blog however the students want it to look. You could also do a book review or a timeline of events that are happening. That could be a timeline of events from a historical perspective, or from the beginning, the middle, and end of a book, or of a narrative or a story. And then lastly, you could also publish a magazine article. So at BSD, we have a template which kind of like has a look and feel of a magazine article. It has, the title and the subtitles and the images, so you can publish your own magazine article. So I think that literature and writing, there's a lot of strong connections, almost as many as there are in maths. But I think that there's a lot of tension between literature and writing teachers to want to do coding. But even though there's a strong correlation between what is available and what students can do, I find that literature teachers are least likely to be interested in coding. So our goal at BSD is to help teachers and show them how easy it can be done, because our guided projects have a step-by-step process in which the teacher doesn't even have to know coding. They just have to be able to facilitate and show students how to move through the steps, and our platform guides students the rest of the way. In social studies or history, as it's called in other places around the world, there are also many different projects that we can do. I mentioned earlier a timeline, which is a versatile type of project, but we can also think about a timeline from a social studies perspective, where you're looking at events that have occurred over a period of time. Like, so you're studying World War II, you're studying a certain event in history. One of my favorite projects is a pop-up map. I'm kind of a map enthusiast. I like to look at different types of maps from around the world and digital maps. But you can kind of take a geolocation and drop a pin onto that, and then using JavaScript, you click on that pin, it pops up, and then there's more information, an image, a description, etc. We've already talked about blog, but we can take the blog and we can kind of give it a new focus. So we could have a travel and culture blog that's based around the social studies subject or the historical subject that you're teaching. Another app that we have at BSD is a hieroglyphic translator. It's very specific towards one particular strand in social studies or history, which is ancient Egypt, but it is a cool project, and it also brings out a bit of cryptography and translation, which then can be helpful in other fields such as maths and in language. So we've kind of just shared across the gamut a wide variety of different projects that can be implemented across the core subject areas. And so when we say the core subject areas, we're talking about the reading and writing and math and science and social studies. Those are typically across almost every school around the world, the core subject areas. And so while most people think that coding is an isolated activity that should only happen in the technology classroom, we're here to show you that coding can be done across all of these different areas and can be added into any subject given the right context and also given the right circumstance. And all that's needed is a teacher that's willing to try. So we've provided some tips for those teachers who are still on the fence about it and maybe need a little further persuasion, or maybe you're just interested but not sure how to start. So here are some tips that we have for you. A lot of times we feel as educators that we need to be the expert in our field. And while it's good for us to have a lot of knowledge on our subject, we don't necessarily have to be the expert when it comes to coding or programming, especially if you use the BSD platform, because we have so many built-in tools and a scaffolded model that helps students learn along the way. But you as the educator can also learn along with the students. So earlier we shared our computational thinking guide. So it might be good to learn with the students by starting with an unplugged activity from our workbook. Another way to get started is to remix an existing project. So let's say you want to make a blog project. Well, instead of starting from scratch and coding the blog from beginning to end, you could take a blog that's already been made, and then all you have to do is change the content, change the images, change the titles, change the description, change the text. And you're remixing that project. Along the way, you're learning about the syntax that happens in HTML, where the tags are, where the body is, where the paragraph is, etc. We also like to remind people that coding is a skill. And so it's like, you want to learn how to play guitar. Well, you don't just pick it up and start playing right away. You have to practice and you have to do things. And you usually start by playing a remix. So you pick your favorite song and you try to play that. So coding is no different from playing guitar, really, or any other skill. Another question or another concern that we hear often is, how do I find time? How do I find time? I'm so busy doing this and doing that. We're not asking you to become the technology teacher and teach coding full time. We just think that it would be interesting to try a little bit of coding in certain subjects because it gives students a new opportunity to share what they have learned while also doing coding and programming. Eva, have you heard about Genius Hour?
Yes.
Have you ever done?
I have not done it with my students before.
I've done Genius Hour a few times, and what I find is that students will have the most elaborate reasoning for why playing a video game is something that they're learning from. So instead of giving up your Genius Hour to have students play video games, teach them how to code, give them a BSD project, and they can make something like a blog. Or if they're really into video games, they could make their own video game. Another thing that you can do is provide students an alternate assignment. So if you are a writing teacher, a literature teacher, and you want your students to write a narrative of some kind, which is a typical classroom assignment, write a book report as an example. Okay, well, they could write it on paper, they could write it on a word processor, or they could make a blog out of it and they could post it online. So it could be an alternative assignment that students have this option. They can code it if they want to, they can write it on paper if they want to. This really ties into what we believe is most important in the classroom with voice and choice. Students should always have an ability to, at some time, to share what is important to them in the method that they feel most comfortable or that they're most drawn towards, or that it highlights their strength in some way or another. And so like I mentioned earlier, try just one. we're not asking you to become a full-time coding teacher, but if this is something that's interesting to you, it might be good just to, pick one project during the first semester next year, try it out, see how it goes, see how your students respond to it, see how it works with you. You may find that it's easy, and you may find that you want to keep doing it. We also like to mention that coding is more than just technology. So coding seems like a very precise computer skill. But what we've learned along the way is that you learn more than just coding and programming. You learn how to solve problems. You learn how to interpret data. You learn how to create content, which are the hard skills. And then the soft skills, by working with other students and working with teachers, you learn communication, collaboration, and critical thinking. So learning how to code is much more than just that technical skill. There's all these other kind of like wraparound skills that are also important and valuable to students. So that's why we say it's more than just the technology, more than just coding and programming. We'll wrap up with a quote from Seymour Papert. We often quote Seymour Papert and talk about his learning approach. He founded a learning approach called constructionism, which is the basis foundation for what we do at BSD education. And he says that often kids in a computer lab learn about word processing, but if they want to write an essay, they write it by hand. This is exactly the opposite of what you want them to learn. They're approaching the computer as just another abstract school subject. So, this quote is probably from the late 80s or early 90s, when computer labs are just starting to become a thing in education around the world. And I often see this happening in classrooms around the world today, is that computing becomes another subject. Like we have computing, then we have math, and we have science. And what Papert is trying to say here is that we should treat the computer as a tool, as a material, so that it can be used across any subject. It can be used across any area. It can be used at any time to solve any problem. So we shouldn't learn how to use computers and then go back and write on paper the old-fashioned way. The computer is a tool, but we shouldn't confine the computer into a tool that's only used at a certain time in a certain period of the day for a certain part of our learning. It can be used to flourish all types of learning across all subject areas. So we hope that this has been somewhat useful to you and inspiring in some way. And we hope that if you are not using coding in your curriculum, that you might be interested in trying. And so I'll hand it back over to Eva, and she'll tell you about some of our free projects and some of our resources that you can use to try coding out freely and with ease.
Thank you so much, Mark. Sorry about that. So yeah, there's, as Mark has mentioned throughout the webinar, some awesome projects that are quite adaptable in different subject areas. One that we love to use across any subject areas, and we always love to suggest to teachers is.
If you could go full screen.
Oh,
so
sorry.
We can see the whole slide. There you
go. Sorry.
Thank you.
All right, perfect. Sorry about that. Where was I? Yes. So my first website is one of the projects that we love sharing with our educators across different subject areas, because it's one of those accessible first beginner projects where students can apply any passion area, or teachers can suggest any subject area or topic for students to create a website on. So the example here is about, it's a website about the student. Or we can also ask students to do a website about their school as well. So it's a really good template that allows students to get creative and feel connected to the websites that they create.
Yeah, Eva, I want to jump in real quick. If you go back to that to my first website, the example is about me, or it could be about the school. But if you think about different subject areas, let's say it's writing. It could be that we're writing about a novel. So there's 3 sections: beginning, middle, end. Let's
Yeah.
take it to science class. All right.
Mhm.
Now we're talking about weathering, erosion, and deposition. Okay,
Yeah.
so get any three things across any subject area, we can change the content and change the titles and change the images. So this is kind of just a blank canvas that's
Mhm.
already formatted to have a title and introduction in 3 sections. So any subject area where you can think of where you want the students to show 3 things, here it is. If you get good at coding, you can even add more sections to this and customize it further. But this is a great place to start for just any 3 things.
Great. Thank you, Mark. So there are 3 main different ways that you can bring BSD into your school. So starting in the new term, since we're in the summer right now, that you can start with the free option, which is Start. There's a handful of projects that you can choose to integrate or to bring into your classroom. Or you can look into Teach, which is a single teacher subscription for up to 30 students. And to integrate fully with all the PD support and the coaching and the live chat within our BSD ecosystem, we also have Build, which allows access to 600 plus hours of certified curriculum as well. So this is the link to, Mark, do you mind sharing the free projects link?
Got it.
Great, thank you. So this is the link to the free projects, and you can find my favorites website right there. So thank you so much for joining us today. This is also a feedback form. We will address some questions that we have. Okay, let's see.
Any questions?
What if I, as an educator, can't help the students when they get stuck in the classroom?
Yeah, that's a common question that we get too, especially if you're new to coding and new to programming and you've got a student who's, out making a physics simulator, and you're still on my first website in your coding journey, but the student's stuck and you don't know what to do. Well, if you're using BSD education, we have world-class 24-hour support in which you can reach our support team. They can look at a live example of the student's work and then solve the problem or offer a tip to help the student solve the problem. And that would be initiated by the teacher. So the teacher can ask and get that direct advice. If you're not using BSD, then you've got to troubleshoot on your own, and then maybe you've got to call the technology teacher and get some help in there. The computational thinking workbook that we shared earlier also kind of helps to unlock critical thinking, and it's called computational thinking for a reason, because there's a certain way of thinking about how to solve problems, no matter what the code level is.
Yeah, I have encountered getting stuck in the classroom as well. And sometimes I just ask another student. So if I can't figure it out and I need an extra pair of eyes debugging the code, I might see, okay, that student's doing really well over there, pull them over and say, okay, let's look at this together, or involve the whole class to help debug a project. But if it's a technical issue, or if it's like a server issue, then of course, like, hopefully we can, with BSD, we can lean on the support team that we have.
Yes.
Another question, still need more convincing, Mark. Why is coding important?
Why is coding important? Well, I think it's kind of like the language of the future, and by not teaching it, you're really providing a disservice to students, because their future will most definitely be impacted by technology. It certainly has painted a clear picture that technology is such an important role in our life. We use it every day. We ought to know how it works. We ought to know, at least to some level, how these things are created and how they're made. We don't expect every student to go out and become an engineer, a coder, or a programmer, but we expect them to have some level of fluency so they kind of know what's going on and how these things work and operate. Because one day they might be, even though they might not be a coder or a programmer, they might work in a business of some kind in which they have to make a decision that's related to the code or the programming. And then they hire coders and programmers to execute that decision. But knowing about it is the first step. So it's something that should be taught to varying levels of degrees. It should be taught to a base level for all students, and then for deeper levels for students who really want to go down that path, just like any high school subject.
Yeah, and I also think that it brings out a different level appreciation of the maybe apps or games or technology that students are interacting with every day. Once they know, like, oh, a game is not, oh, it's not magic. Sometimes I hear students go like, wow, this is like magic. How do you make it? Like, once they understand the code behind it, it kind of demystifies it, and then it kind of opens up a whole new understanding to a new industry, and maybe even possible like aspirations as well. So yeah, cool. So thank you so much for joining us today, and you will be able to find this recorded webinar on YouTube in a couple of weeks or days. Thank you so much.
Yep. Thank you. See y'all later.
Bye.